Hello YouTubers, fellow hams. Well, sitting on the bench today, I have another donated piece of hardware. This is an MFJ 962D 1.5 kilowatt roller inductor antenna tuner. 1.5 kilowatt. Yeah, okay. Well, the manual says 800 watts RMS. So in my mind, that's an 800 watt tuner. Sure. Technically, you can get up to 1.5 kilowatts peak, and it'll tolerate it, supposedly. Anyway, this was donated by Al, and Al, you know who you are. Thank you very much, Al. The history on this one is he sold it on eBay, and the guy that bought it contacted him right back and said, hey, this tuner's burnt, and sent it back. Yeah. There's a burn inside. We'll get to that momentarily. But Al, he didn't want to deal with it anymore, so he knew I did YouTube videos, and he said, yeah, I could have it. You know, I could fix it or do whatever with it. So we're going to take a look at the issue, try to get it corrected, and then this is going to go to a local new ham. Exterior is pretty good shape. I've got the light on right now. I've got the power on it so you can see the meter light. It looks nice and bright. It's got an LED light in there. We'll open her up. I already took the screws out. There's 4, 8, 12 screws on the case. But let me swing the camera around here and we'll take a look at the inside of this beastie. So like most of these higher end tuners, we've got 3 major components, 2 capacitors and an inductor. And this is a roller inductor, meaning that inside here, right here, there's a roller that's on a conductive shaft. And as you rotate the knob around, that roller follows the winding of the coil and moves along this shaft, so you can adjust the tap anywhere along the coil. And then 2 big capacitors, and here is a ball in at the back for the twin lead feeders. You can't quite see it, but one of these is bent in a little bit. It took an impact on shipping and punched this, and it's just angled just slightly. There's a little dent here. You can kind of see it on the camera there. Pretty thin metal. The ceramic insulator wasn't even chipped by the impact. The metal gave way instead, so that's how thin that metal is. Don't know if I'll worry about that too much, considering what's going to happen with this tuner, but we'll get to that later. So what's wrong with this guy? Well, if I swing that around and zoom in, you'll see right here, there's some burn damage. Let me zoom the camera in. Now as you can see, right there on the side of the inductor, we got a lot of carbonation going on here and some smoke damage up here on this material. And I already took it out, but there was something in this hole. And what was in this hole was this little switch assembly. And as you can see, we got a burned piece on it as well, right there. Now, this puzzled me, this little switch assembly. I didn't know what it was doing. But first off, to the burn, what happened here? Well, probably what happened is somebody tried tuning while they had high power running through this thing. A few hundred watts or so, and they were probably fiddling with the inductor with high power going through it. You never want to do that on a tuner. You want to do your tuning at low power and then turn your power up after you got it tuned. So what probably happened is they rotated this inductor past this area. It engaged this little switch assembly, which the way this worked, this was in here, and as the roller would move past, it would bump this, and that would flip it over, making this contact engage the coil. And then as the roller went by in the other direction, it would bump this one and lift that up, disengaging it from the coil. And what this rod was doing was it was shorting off half the coil. What? Yeah, that's what I said. What? Well, to understand what's going on, I looked this up on MFJ's site, and this is one of their trademarked features called a self-resonance killer. Let's go look at the schematic for this tuner, and I'll explain what that was supposed to be doing, at least as far as I understand it. So here's a simple diagram of the two most common types of tuners. All right. The L-network tuner is by far the simplest. You've got your input, your output to your antenna, this goes to your radio, and you've got a variable tap on an inductor and then a variable capacitor to ground. Very simple tuner, somewhat flexible, pretty useful. I built one in another video and talk about it there. The other most common type is the pi network tuner. And the pi network tuner has got its name because it kind of resembles the symbol for pi. So you've got an input here, again, your radio, a variable capacitor to ground, then you've got your tapped inductor, another variable capacitor to ground, and then the output to the antenna. And that's the pi network. This MFJ is a third type, not as common, I didn't think, but I have seen them before, known as a T network tuner. And that's the way it's laid out. Input from the radio goes through a variable capacitor, then you've got a variable tapped inductor to ground and a variable capacitor to your antenna. So that's the T network tuner. So what is this little doohickey switch that's shorting out the coil halfway to ground? Well, what's happening on that is you can think of it like this. A switch and this is not variable. This is hardwired to that point, not quite halfway up the cable. And what happens is, as you're rotating that inductor and you're moving this tap point up, when it reaches this point, that switch closes. And then it continues on up here. And then when it comes back down and it reaches that point, that switch opens. And then it continues on down. So what is this doing? Well, MFJ calls it a self-resonance killer. And they don't really specify on their site that I've been able to see what that is, what problem that is solving, what they're referring to with self-resonance. Now I can speculate, and this is only speculation, okay? I'm just guessing here. I would guess that as you have this tap up further on the inductor, that this wire is going to have some parasitic capacitance against the metal of the coil. Just a teeny tiny amount. But what you would end up with is from this point down, you'd end up with a coil in parallel with a little bit of capacitance, a tuned circuit. And that maybe, although it looks like you're just shorting out this part of the coil here, maybe there is some kind of interaction that can happen there and can cause the whole thing to become a resonant load at the frequency you're at, meaning that the power coming in would be eaten and turned into heat in the coil. Now I'm just guessing on that, and I would think that what they did by adding another short, that they have decreased the DC resistance and somehow killed that or reduced that self-resonance possibility. I'm just guessing. This doesn't exist on any of the other tuners that I've seen, and it's a trademark on an MFJ site. So it's one of their innovations. So if I was going to sell this tuner on eBay, I would worry about getting this fixed and replaced so that it would be intact and the advertised feature of the tuner would be present. But I don't know if I'm going to be able to fix this thing. These are specially cut little pieces of really thin PC board material, and this is a hexagonal shaft, so you'd have to punch a hexagonal hole through some material, cut it just to the right shape. It'd have to be really thin. Yeah. You know what? I think I'm not going to worry about this. My plans for this tuner, I'm not going to sell it on eBay, so I don't have to have it exactly as it was when MFJ built it. So I think I'm just going to leave their little trademarked feature out of there, because this tuner is going to go to a new ham. And honestly, I know the guy, he's never going to put more than 100 watts through it. So I'm not going to worry about fixing this because that's just burned completely away. There's just no salvaging that. So let's look at the burn on the tuner again and figure out what we need to do to clean it up. So what do we got going on here? Well, we've got some carbon on the outer part of that winding there where it definitely arced on the winding. And we've got some carbon on there from the flash, from the burn. I'm going to take a toothbrush and some alcohol and let's just see if this stuff comes away. Yeah, it looks like I can get most of the carbon off this way. Well, some of it anyway. I think for the windings on the coil, I'm going to have to get a slightly abrasive cloth and maybe a little bit more, something a little bit better than alcohol. Well, I don't know. The carbon is coming off. It might just take some elbow grease and time here. Let me work on this for a little while, see if we can get that cleaned up, and I'll come back to you. Of course, the trickiest part about cleaning this thing is getting the inside of the coil. You can see what I've done here. I've got this piece of rag that I've snaked through, and I'm just spritzing it with contact cleaner and then working it. And just working on it. It's coming off layer by layer. It's just taking time, lots of time. But it's definitely coming off. So I'll just keep at this for a while and we'll get this coil all cleaned up. Then we'll look at cleaning the roller inductor because it, or the roller connector, because it took a bit of a hit, I think, when it flashed over at this point. Well, managed to get it pretty good. The arc had pitted the material here a bit, and as I got the carbon off of it, you can see a little copper showing through under the silver plate. But the roller makes contact around the full almost half the circumference of the wire on the inside. So being that I know that this tuner is going to be employed by somebody who's probably never going to do more than 100 watts, and I'll probably warn them against that, I think it's going to work just fine at that power level. You know, maybe even a bit more. He might be able to get up to 200, 300, 400 watts just fine, as long as you don't try to tune it while you're running that power. So that's a big problem with these tuners. You always want to drop your power down to 5 watts or less when you tune initially. And then once you get it in place and tuned, you can crank your power up, and you could fiddle with the caps a little bit, but you wouldn't want to rotate the inductor when you're under power. Okay, so now we've got to clean the roller. Let me swing this around so you guys can get a view of it. Yeah, let me zoom the camera here and show you how dirty that thing is. Well, here you can see the roller right here, and you can see how that, as you turn the knob, how that just rotates and follows the windings of the inductor and slides along that shaft. And if I bring it back around here, you can see how dirty and filthy this thing is. It's got gunk in it. Yuck. So we're going to clean that, and this is going to be a little easier to clean. I think I'm just going to need the toothbrush and some alcohol. And I should just be able to oh yeah, that's cleaning right up. Can't get to the other side of it there. I can get to it there. Yeah, that shined right up. Can you see that? Looks like metal again. A few spots yet. So we'll get that cleaned up. And I think, yeah, that looks good. That looks a lot better. I think we'll probably be okay on this tuner. I'm going to put it back together and hook up the little ICOM 725 that I had on the bench in the last video and my external end-fed wire, and we'll do some tuning with it and see how it behaves. Okay, I have the beastie all hooked up. My external 98-foot end-fed wire is connected in on coax 1, and I've got the little ICOM sitting here. I've got it on 17 meters. It's nighttime, so I'm not too worried about interfering with anybody. And the first thing I wanted to check, that part that was burned on the inductor, I looked at the counter, and it's somewhere around 65 to 70 in that range where the inductor goes past it. So I want to listen to the radio, roll through that area, and make sure it's not noisy. Okay, I don't hear any scratchiness, so it's maintaining a connection. Alright, so to tune with this guy, the first thing you do, you put your capacitors at about the halfway point. I got them both on 5. And then you'll roll the inductor to find the place where the radio's noise level comes up. And that's probably going to be up near the lower inductance end. Right around there. All right, and then you'll fiddle with the capacitors again, listening for noise peak. Right about there. So now I'm close, and I've got the radio's power set to 10 watts. Like I said, you want to tune with low power. Yeah, we're pretty close. Not too much reflected power at all. So now all we have to do is just tweak the capacitors a little. Well, I'm almost at 0, so I'm going to add a little inductance and then try again. Okay, there I'm seeing a dip. Let's try and change that just a bit. I'm trying to get that right down to 0. Unreflected. Alright, let's go in the other direction a little bit. Oh, there it is. Well, now we don't have too much. Let's add just a little bit more. Nope. Nope, that took us out of the range. Okay. There we go. Hardly any coming back. So we've tuned it for 17 meters. Now let's switch bands. Okay, 20 meters is nice and quiet. Again, I'm going to put my capacitors about halfway, and I'm going to find those noise peaks. All right. There we go. And there we are. About, well, okay, about 20 watts forward. Drop that power a little bit. Yeah, about 20 watts forward, no reflected. So, yeah, the tuner's working just fine. Well, that's 20 meters. It's night. I should probably ID. let's go all the way to top band. There's 160 meters. Now I'm going to have to spin that inductor a ways, I bet. Here it comes. Okay, now I got to find a clear frequency. Oh man, there's a CW contest this weekend. Okay, there we go. Oh, look at that. No reflected power at all. Yep. Just tuning by ear for the noise peak actually got me right on for 160 meters. All right. So, hey, the tuner works. It's going to go to a new ham. Like I said, if I was going to sell this on eBay, I'd probably contact MFJ and see if I could get that part. But I'm not going to bother with it because as it is, it's going to work fine. Especially at 100 watts, it's going to work fine. It's got way more capacity than it needs for that. So I think it'll serve the guy pretty well. He's only going to be using it with this radio. So this will be pretty much a station for a new ham here in town. He's going to be happy with this, I think. Anyway, that was the burned up MFJ 962D. Looks like it's going to work. Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.